All right, since we are through with the mass concrete, that's plain concrete, we move to reinforced concrete, and we have made provision for the grade, which is 25 kg per millimeter square. That's 25 Newton per millimeter square rather. So we also look at the horizontal work in structure, which is above 300 mm thick, and in this case we are looking at the column bases again, and we are looking at the column base footing. Look at it, has been provided already, a thickness of 450 millimeter. So it also follows the same pattern. All we need to do is to book the length and the width of the column base. This for base 1 we slash by 11, and this for base 2 we slash by 4. And here we make provision for the thickness of the footing, which is 0.45 meter. So once we multiply this by these quantities, we have the concrete to be in cubic meter. So we also make the deduction and addition just as we have earlier described. So once we are done with this, we now move over to ground floor slab. In our section, we have 150 mm concrete bed, which is this. So it cut across the entire space, the area of the building. So that's why we have 25.23 meter by 16.73 meter. How did we get this? We've done this already, which is the total length from here to this point multiplied by the total width. If you add this and this, and you deduct the half of the column base on both sides, you will have this 16.73. and if you add from here down to this point and also deduct half of the column bases at both ends, you will end up having 25.23 meter. So because we took it as a whole, remember that we have a void here, meaning that the concrete slab will not extend to this point. So we're going to make deduction from what we have established. That is why we have made this deduction. Deduct for void, which is 13.00 by 6.00, which is, how did we get the 13? We added this length to this point and the width from here to here to get our length and our width. That is what we have just done. And next thing we are considering, we're going to consider will be our concrete in the starter columns. So, but before we go over there, we need to establish the height of our column from the concrete footing, and as well the height of that column in foundation in the case of considering, if we want to consider for backfilling or the quantity to be deducted from the backfilling content, then we need to establish the height in foundation first. So the actual height of column starter, judging from what we have at this point, if you look at it, we from the concrete bed to the natural ground level is 600 millimeter, and from the natural ground level down to the bottom of the footing is 1300 millimeter, and the thickness of the blinding is 50. So in that case, we go ahead to add 600 plus 1003 plus 50 will give us 1950. So we will go ahead to less the thickness of the slab, because it will not be part of the column. The height of the column will less the thickness of the blinding, which is 50. That's the concrete blinding on top of the hardcore. We also going to less the blinding in the foundation, not on top of the hardcore rather. So we also add the thickness of the base, which is 450. When we add all this, it's going to give us 650. So when we minus 650 plus 1950, we will end up having 1300 mm. This now forms the height of our column, our starter column. That's from foundation footing up to a point before the concrete bed. Now we also consider the height of our column in foundation. So we take from the natural ground level, because when we want to fill, when we want to do backfilling, it will start from this point to a point at this level that is below the natural ground level at the reduced level. So that is why we're going to pick this 1003. We are picking it from this natural ground level up to the footing. Now we have 1003. We go ahead to less the topsoil. We less the topsoil to get to a reduced level, because our excavation commences from the reduced level, and we also less our base, which is this thickness, this height, which has been given as 450 millimeter. When we less all these from 1003, we will end up having 700 millimeter. All right, having established the height of our column starter to be 1.3 and the height in foundation to be 0.70, we go ahead to book for the vertical work concrete in the starter column. The size of the column for base 1 or column type 1 is 225 by 225 as indicated in this section. Column type 1, 225 millimeter by 225 millimeter, and for column type 2 we have 450 millimeter by 225 millimeter. So if we are booking for our concrete work in starter column, it will now be the size of the column itself multiplied by the height. In the case of column type 1, it will now be 225 millimeter by 225 millimeter by the height, which is 1300 millimeter. But mind you, when you are booking in the taking of sheet, you convert all these figures into meter. So this one will be 0.23 by 0.23 by 1.30. So that is how we got this figure. 0.23 by 0.23 by 1.30, and we have it to be 11 in number. We slash by 11, and that of column type 2 is 0.45 by 0.23 by the same height, but in this case we have 4 number, so we slash by 4. And because we have made provision for the height of this column in foundation, this will enable us to know the volume of material we are either to deduct from filling or to add for disposal. So in that case, we have the size of the column 0.23 by 0.23 by the height of the column in foundation, which we have established to be 0.70, and we have it as 11 number. We do the same for column type 2, and we have the description already: vertical work less or equal to 300 millimeter thick in structures, which is in starter column. And all this concrete you are treating are reinforced. So we look at the deduction, which is filling obtained from excavated material just as we have earlier described, and we add what we are going to remove to deduct from this into the volume or quantity we have for disposal, and that is what we have just done. And we move over to formwork. We are looking at formwork to sides of foundations and bases, and we will also look at formwork to edges of horizontal work, and lastly we'll look at formwork to sides of attached columns. Now, starting with the first one, which is to side of bases, we know that our base one is a square base which is 2 meter by 2 meter. So in that case, we just book one side of it and slash by the number of sides. So look at what we mean. We need to place formwork here at this point and at this point. So we just, since it is a square base, we just pick one side. Since this side is the same in terms of the length of the other remaining 3. So we pick one side and slash by the number of sides, which is 1, 2, 3, and 4 sides. So that is why we have 2.0 meter by 4 sides by number of column bases, which is 11. Now for this column base 2, since it is a rectangular base, it means that these two sides are equal and these two sides are equal. So it means that we pick one of this side that is equal to this and slash by 2, and pick this side and slash by 2. So we have it to be 3 for the first side, 3.50. We slash by the 2 side which has the same length as 3.50 by the number of bases. Our column base 2 is 4 in numbers. That's why we are slashing by 4 again. Then we now pick the next side of the column base 2, which is 2.00 meter, slash 2 sides that have the same length, slash the 4 number of that base. So we have it, we go ahead to this, the description, side of foundation and bases, and the height of it ranges within 500, less than 500, or to 500 millimeter high. Then we also look at from to edges of horizontal works. So in that case, we are looking at formwork to slab, that's concrete bed. Formwork to concrete bed. In that case, we will have 25.23 meter slash 2 and 16.73 meter slash 2. How you know how we got this? It is, we are forming the length of the building and the width of the building. Since this width is the same as this, because there is extension of the length here, and this length here is the same as this and this extension. So we have this slash 2 and this multiplied by 2, that's slash 2. So that is what we have just done, 25.20 slash 2 and 16.73 slash 2. So the description is edges of formwork to edges of horizontal work less or equal to 500 mm high, or in this case we are looking at 150 millimeter wide. So we now finally look at the formwork to side of the attached columns, because since we have starter columns or concrete, we've done that already, we need to also look at the formwork to starter column. So in this case, for column type 1, which has the 4 sides equal, which is 225 millimeter. In meter it is 0.225, which is approximately 0.23, and the 4 sides are equal. So we just pick one side, multiply by the height of the column we have established as 1.30, then we multiply by 4 because this column has 4 sides which are equal. and it is 0.23, so we slash by 4 and slash by the number of columns, which is 11. Then in the case of column type 2, we just pick the first side, which is 0.45, which two sides are equal in terms of this length. We slash by 2, slash by 4. Then we pick the other side, which is 0.23, slash again by 2 and by 4. So all these, to be in as a superficial item, we multiply by the height of the column. So you look at the description, which says some formwork to side of attached columns, and we have 11 number, regular shaped, which is a square in shape. And in this case, in the case of column type 2, it is 4 in number but rectangular in shape. All right, we are through with the concrete measurement. So we now move over to reinforcement. We want to measure the reinforcement bars, both in column starter and in column bases. So in terms of the column starter, we have 4y20 as indicated in the section, which is 4y20. If you look at here again, you see that we have 1, 2, 3, and 4, which is 4y20 at this point. The same with column type 2, the same 4y20 as starter bars. So we want to establish the length of this starter bar from this point where we have bend up to this very point. And you know that we have it to be 4 numbered in a column. That's 4y20 per column. And for column type 1, we have 11 columns, and column type 2, we have 4 columns. So we go ahead to establish the height of this y20. Remember that from natural ground level up to this very point, we have it as 1003, and from natural ground level up to this point of where we have the concrete slab, we have it at 600, and we have 75 here and 750 millimeter projection of the reinforcement bar. So if we want to get the total height or length of this reinforcement bar, we add from this up to this very level, and we add our bend, which is this bend here. So we go ahead to add 1003, which is from natural ground level up to this point, plus 600, which is from here to here, plus 75, which is here to here, and lastly 750. So when you add these figures, you will have 2725. Then we have made provision for concrete cover, which we must less concrete cover from the established length. In that case, we less 25 millimeter concrete cover. We will arrive at this figure, which is 2700 millimeter. And for us to add this bend, since it is at one end, we multiply 9, which is constant, by the diameter of this reinforcement bar, and the diameter is already given as 20 millimeter diameter. So we now multiply our 9, that is 9D, 9 times D. D stands for diameter. We have 9/20. This 20 is the diameter of the bar. When we multiply this, we have 180. So we go ahead to add this and this. We have 2,880. This now stands as for the length or height of the column starter bar, just for one column starter bar. So having established the length of Y20, which is in the column, we now go ahead to establish the Y16, which is in the base. If you look at the base, we see that we have Y16 at 250 center to center spacing, both up and bottom. On both sides, we have Y16. So we want to establish the length of this Y16, and then we multiply by the number of Y16 that will fill this space, this base. So for base 1, which we have the length as 2 meter, that's 2000 millimeter, we less the concrete cover. In this case, we less this allowable space to be filled with concrete. You can see that there is a tiny space here, and based on what we have established before now, we assume 40 millimeter concrete cover in base, in foundation. So we less the concrete cover, which is 2 times 40 to give us 80. When we less 80 from 2000 millimeter, we have 1920 millimeter, and this is not the actual length because there is also a provision for bend, or what you call hook, or at both ends. So in that case, we go ahead by using our formula. That's 2 times 9 times the diameter, and in this case the diameter is 16. We have 2 times 9 times 16, and it will give us 288. So we go ahead to add this 288 to 1920. We have 2208. That's the actual length. So this is just the length of one, but we want to know the length, the number rather, that will cover this entire space. So in that case, we take the length, which is the 2000 minus 80. That's the concrete cover, which is 1920. We divide it by the center to center space, which has been provided as 250 millimeter. We divide it with 250, and it will give us 7.68 plus 1 as the based on the formula, which is the length over center to center space plus 1. So if you divide this by 250, you will end up having 7.68 plus 1, which is constant. So this is 8.68, and it is approximately 9 numbered. This is just for column base 1. So since they both sides have the same length of the same dimension, there's no need repeating for the other side. So we only consider that for base 2, whereby we have the length to be different from the width. The length is 3500 millimeter and the width 2500 millimeter. So we still do the same thing we have done for base 1. We have the length, we less the concrete cover, arrive at this length, we add our bend 288, and we arrive at this figure. And for us to know the length, the number of bars that we fill up the base, we now divide 3420 after we must have deducted our concrete cover of 80 millimeter. That we divide by 250, and we end up having 13.68 plus 1, which is constant. We will have 14.68, which is approximately 15 number. All right, having established the length of Y20 and Y16, we will go ahead to also get the length of our Y10, which is the link, or the what you call the stereo. In this case, what we are talking about is this link around this. and it's the same as this for column type 1. So we look at get for column type 1, where we have the length and the width to be the same, 225. So what we do is pick one side and slash by the 4 sides, since they are all equal. So in that case, we have 225 slash 4 to give us 900. So we must less concrete cover, which is 4 slash 2 slash 225, which is 200. Then we minus this from 900, we'll have 700. We'll go ahead to add our bend, which is 2 times 9 times diameter. Our diameter is 10 millimeter, so it will give us 180. Once we add 700 to 180, we have 880. So we want to know the number of this link. How do we establish the number of the link? We take the length of our column starter, which is this that we have established already, because the link is going to kind of combine or has a connection with the starter bar, that's the Y20. So we're going to look at the length which we have established as 1.3, which is 1300 millimeter. We divide it by the number, by the center to center space, which has been given as 200, Y10 at 200 millimeter center spacing. So if we divide 1300 by 200, we will end up having 6.5 plus additional 1, which is constant, which will give us 7.5, which is approximately 8 numbers. So we go ahead to get or the length for column type 2, where we have 2 sides equal and the other 2 sides equal. The first 2 sides that are equal is 450. So we pick one side, which is 450 slash 2, to give us 900. The remaining side, which is 225 slash 2, to give us 450. Adding these two together, we have 1350. We also go ahead to less the concrete cover, which is 200. We add our bend, which is 180. We end up having 1330. So we go ahead the same number of links, just as we have done here for the number of stereo or link. So that's why we just brought, instead of repeating this, we brought it back to this one, since they have the same length. They have the same length in common. So we have established the length of a number of the individual reinforcement bars. So we go ahead to describe a high yield reinforcement bar to British standard. That's this 4461, and for 20 mm diameter, which is straight and bent. In column starter, we book the length, or the length of the bar, which is 2.88. Remember that we had already established this length from this point where we got 2880, so which is 2.88 meter as the length slash 4 number, because we have it as 4 number. We have 1, 2, 3, 4, and it's indicated here already as 4Y20. So we slash by 4 times also the number of columns. So in this case we have 15, because we have added the column in base 1 and column type 2, that is column type 1 and column type 2. Type 1 is 11, type 2 is 4. So when we add the 2, we have 15 number. So we also book for the Y16, and in the case of Y16 we have 2.21 as Y16, which we established here. You see Y16 2208, which is 2.21 meter, 2.21 meter, and we have it 9 number. We have it 9 number. That's why we are slashing by 9/2/11. That's for base 1. For base 1. Then we have 2.2 again, which is the length, /15/4. So this figure is for base 2, that is column base 2, where we have it as 15 number, which is here. We have it as 15 number. That's 13.68 plus 1, which is approximately 15 number. So having established the length of our reinforcement bars and the number respectively, we go ahead and book for higher reinforcement bar, both straight and bent, in column bases and of course column starter. So we go ahead to book the quantities. For the Y20 we have 2.88. That's the length of Y20, which we establish from here. Y20, the length is 2,880 millimeter, which is 2.88 meter. So, and we have it 4 number slash the number of columns. This 15, which is 15, this 15 is the number of columns in base 1 and base 2. Base 1 is 11 and base 2 is 4. So when you add 4 and 11, you have 15. So that's why we are slashing by 15. Then we move over to Y16. This Y16 straight bed in the column base, so which is 2.11. How did we get that? When we measured for our Y16 in base 1 is 2,208, which is 2.21 meter. And of course we have it to be 9 number in both way. That is this way and this way. We have here as 9, sorry, for base 1 we have here as 9 and we have here as 9 number. So that's why we will slash by 2 by 9. So we have 2.11 /9 number /2 / number of bases, which is for base 1 is 11. So we move to base 2, which is one side is 2,000, the other side is 35 millimeter, 3,500 millimeter. So the side for 2,000 shares the same length with this, so which we have 2.21, and this is where we still got it, and the number is 15, which is we use this length to determine the number of the other side, which is 15 number. 15 number for 13.68 plus 1 is 14.68, which is approximately 15. So that's why we are slashing by 15 / number of base. Base 2 is 4. Base 2 is 4, so we slash by 4. And then for the other side, which is 3.71, shares the same number with the side, which is 2,000 meter, so millimeter rather. So we have this /9 / number of base 2, which is 4, and that is how we got this. And for you to, most times you in your taking off, your quantity might be in meter, but when you are transferring to your bead, it can be in kg or in ton. So for ton, you will just multiply this for Y20 and multiply your figure here with this for Y16, and that give you the figure to be in tone. So we continue for Y10, which is your length. And remember, we have already established the length of the link to be 0.88. This has been established already to be 0.88, which is this. When we were calculating for our link, the get for column type 1 is 880 millimeter, which is 0.88 meter, slash the number is given as 8 slash the number of the base 1 is 11. So we go for the other base, which is base 2. The length of the link was also established as 1330, which is 1.33 meter, slash the number, which is also 8, slash the number of base. The number of base is 4. So whatever you generate here to be in your squaring column, you multiply by this to give you the figure in tone. And the last to be considered under reinforcement is your BRC mesh. Your mesh covers the entire area of the building, where we have the length as 25,225, with less our concrete cover, which is 40 mm on both sides, which will give us 80. So when you less this, you have 25,217 millimeter. The same you do for your breadth, which is 16,007. We have established all these figures before now. So we less our concrete cover 80 and this. So we just go ahead and describe the weight of the BRC mesh, and we book 25.22 by 16 is a superficial item, so its area 25.22 meter by 16.65 meter. So since we treated this as a whole, as a rectangular base point, that is the surface of the building, we need to deduct for the void, which we have been doing before now. For the void, which is this section, this point which we have done during our topsoil excavation, filling, and the rest, we deduct for the void. And that's what we have also done in this point, which is 13.00 by 16.0. All right, the last item on the list of taking off for substructure is masonry, which has to do with block work in foundation in trenches. So we want to establish the area of block wall in the foundation, and to start with, we look at the gate for block walls, for single wall and double wall. Starting with the single wall, we establish the length of our single wall, which is 25,000/2, millimeter/2. That is the total length of the building when you add all this, which we have done before now. And this 50,000. Then we also add another horizontal length, which is this 12. I believe you can recall we have done this. It's just to re-emphasize on what we have done before. And for the width of the building, we have 16,500/2 to give us 33,000 millimeter. When we add all this, we have 95,000 millimeter. So, but that's not the actual length for the single wall, because we have some intersections, we have some connecting point with the column bases. So and the column itself. So we're going to less twice half of the column size of the column for column type 1, which is 225. So because this our block wall is going to stop here, but our dimension got to the center of this column. So in that case, we must deduct half of this column to enable us get the actual length of block wall, which we stop at the edge of the column. So that's why we are deducting half of the twice of the columns at the corners, twice half, because we have it this way and this way and this way. So, and for the other width, we still have it this way and the other way. So for the corners, we have 1, 2, 3, 4, and 5. We have established this before now. So that's when we multiply through, we have 1, 1, 2, 5. So we also deduct full length of the column, which are cut in the trench line, which include this and this, which we have established before now to be 6 numbers. So 6 times 225 will give us 1350. Now we also have other columns that are cut trapped in the trench line, which is column type 2, 450. In that case, we are talking about this and this. So we deduct the full length of this column is 450 this way, 450, 450, 450. So we have 4 of them, 4 slash 450 to give us 1,800. When we add these and these and these, it will give us 4,275. Deduct this from 9,500, 95,000 millimeter. We have 90,725. This is now the actual length of a block wall for single wall. Now we move over to double wall, which has to do with this wall and this wall. So in that case, we have the length, which is 10,500/2, since we have 2 of the double walls. So we slash it by 2. How did we establish the 10,500? To re-emphasize it, it's gotten from the addition of this plus this. So we also less twice half of the column itself, twice half of the column. In that case, we are looking at this point, and this point. And since we have 8/2, that's why we slash it by 2 and another 2 to consider the 2 double walls. So in that case, we have 450. That is this times this. All through will give us 450. When we deduct 450 from this, we have 20,550. So this is now the length of the double wall. So having established the length, we're going to go ahead to establish the height of the block wall itself. And the height of the block wall, which we have done before now, is 600 plus 950. 600 plus 950 will give us 1550. So what to further show you how we got this, we need to look at the section of this particular plan to particular wall to establish how we got this 1150. And in that case, looking at the section, you have 950 here from natural ground level to bottom of the foundation, and 600 from natural ground level to the point where you have the concrete bed. So that's why we have 600 plus 950 to give us this. But this is no longer, it's not the actual height of the block wall in foundation, because our block wall, which we start from this top of concrete footing to a point below the concrete bed, which is here, will be the actual height of our block wall. So we're going to deduct 150 mm for the concrete bed. So that is why we will less our concrete bed, less our footing, which is 225 mm. 225 mm. We also less our blinding because this 950 extended to the bottom of excavation. So that is why we have these to give us 425. When we less 425 from 1550, we have 1125. So this is the actual height of block wall itself. But we'll go ahead to also establish the height of wall in foundation in case of deduction, to consider for filling to excavation and the excess material to be disposed offside from the total volume of excavated material. So in that case, we are looking at this very height from this point to the bottom of excavation, which is 950. We less the topsoil, which is 150, less the concrete footing, which is 225, less the blinding 50, and we have 425. When we less 425 from 950, we have 525. So having established these figures, we go ahead to describe and book wall, that's measured work. We look at wall, concrete solid block walls in stretcher bond, cement and sand 1:4, mortar 225 mm overall thickness, block wall for mechanically. So for the single wall, we have 90.73. Look at it, where we got it, 90.73 by the height, which is 1.13. This is 1125 in millimeter. We convert it to meter, which is 1.13 meter. So that's the height of the block. So we also do the same for that of double wall. In that case, we have 20.55, because we established this already as 20,550 millimeter. In meter, it will now turn to 20.55. So the same height they have the same height from the foundation, so which is 1.33. So the overall thickness is 475 because it's double wall. So, and then we look at the deduction and addition that should be made to compensate for the filling. That's filling obtained from excavated material. We need to deduct this quantity from the material that are to be used to feed back to excavation, and also add it to the volume or quantity of material to be disposed offside, just as we have done earlier, or just as we have described before now. So having done all this from the first item, which is site preparation, removal of trees, we look at our topsoil excavation, trench excavation, leveling and compacting, anti-termite treatment, form work, up to where we have blinding and concrete footing, to the point where we have block wall in foundation, which is this last one, our concrete wall. All these have been captured under substructure, and since we have been able to discuss all this, I believe that you've gotten the knowledge on how to measure for substructure, which include all items up to and including concrete in bed. Thank you so much for watching. If there be any question or any contribution, you may wish to drop it in the comment section. See you in the next edition. Thank you.